everybody, I'm Michaela Webb. I'll be doing my project on optical illusions. Optical illusions, also known as visual illusions, are made using shapes, colors, light, and patterns to create a visual effect that appears to be different from reality. Our brain works to try and make sense of what is being observed, and in doing so is not able to interpret the actual image. I have recreated a few simple optical illusions to help us understand how they work and to allow students to try and communicate and explain what they are seeing. My activity is designed for grade 2 to grade 4 students. Grade 2 students should have the ability to know and draw shapes, and grade 4 students can be challenged in the activity to identify parallel lines, perpendicular lines, equilateral, quadrilaterals, and other elements of geometry. Now that we have a bit of an introduction to what we'll be doing, let's get into the fun stuff. We are going to identify the optical illusion in each of the following optical illusions that I have drawn. Your challenge will be to describe the visual and then identify what the optical illusion is, then explain how you're able to determine that the visual is in fact an optical illusion. I will help you along the way. To start, we have the tilting tables created by Michael Bach. When you look at the image, what do you see? I see two quadrilaterals. The top quadrilateral appears to be balancing on top of a small triangle placed between the two quadrilaterals. There is also a larger upside down triangle balanced on the top right corner of the top quadrilateral. The top quadrilateral has diagonal lines from bottom to top directed towards the right, and the bottom quadrilateral has diagonal lines from bottom to top directed towards the left. Okay, so now that we've taken apart the image, let's put it back together again. What do you notice about the visual as a whole? The top quadrilateral seems to be tilting downwards on the right side of the small triangle. How do we know that this is an illusion? If we take a ruler and measure the distance between the two quadrilaterals, we can see that they keep a fixed distance apart from each other, which means that they are parallel lines. So here the two quadrilaterals are 1/2 centimeter apart. They are also 1/2 centimeter apart here in the middle and on the other side. Thus, we know that the appearance of the top quadrilateral tilting downwards to the right of the small triangle is only an illusion. Next, we have the cafe wall illusion, created by Richard Gregory. Okay. What do you see when you look at the visual? It may appear to you that each row of black and white quadrilaterals slants. However, the rows are parallel to each other. We can determine that the rows are parallel by measuring the distance between the top and the bottom of a row. So here it is 3.5 centimeters. It is also 3.5 centimeters here. And to no surprise, 3.5 centimeters here. And really any point in the visual, you can measure the distance between the top and the bottom of a row, and it'll be 3.5 centimeters. So we can determine that the rows are parallel because they are a fixed distance apart. There are other versions of the cafe wall illusion which involve different shapes, colors, and shades which make the illusion appear more vivid. We're now going to learn how to draw an optical illusion called the Herring illusion, created by Carl Ewald Constantin Herring. Okay. To make this a quick task for kids, I marked the endpoints of each diagonal line that we'll need to draw using numbers. For example, we have an endpoint at the bottom of the page with the number 1 beside it. So we'll draw a line that connects it to the point at the top of the page that also has a number 1 beside it. So essentially you draw a line connecting the matching numbers, and you do so for all the points that go around the perimeter of the page until all points are connected to another point. Here you can see we have two parallel blue lines. The parallel lines can be any color you'd like, but I happen to like blue. I've also drawn a line vertically through the center of the paper and a line horizontally through the center of the paper. Where the two lines intersect, we can draw a point. From now on, when we are drawing, it is important that each line intersects our point. The parallel lines can be distorted so that they appear bent. We can do so by drawing diagonal lines through the center of the paper, as such. When you have completed the activity, turn your attention to the blue parallel lines. Do they appear to be parallel? Do they appear distorted? It looks as though the two lines diverge at the middle of the page. Essentially, that is the herring illusion. Here's a video of the activity in action that I have sped up. Thank you for watching my video. Here's one last glance at all of the illusions. I hope you enjoyed and that the video was fun and informative.